So hi, I'm Daniel Lemay. I am a developer at Phase 2 Technology, and I am here to talk to you about GraphQL and how it can help improve your APIs and as well as make them more discoverable and a joy to use to your front-end developers. Out of curiosity, who has heard of GraphQL? Most everyone. Who has actually used it? Even tinkering? So about half of the people have heard about it. All right. So I know when I first got into GraphQL and started looking to it, like seemed like this big, ominous, scary thing. And a lot of people that I've talked to have like, oh, GraphQL, that's like really complicated. Like, I don't know if I can get into it. Well, it's not. So I'm hope to kind of give an introductory overview of what it is and what some of the problems that it solves are. And give you some tools to get started with it if that's something that you're interested in. So first I want to talk about something that I don't think we always keep in mind, and that's latency. Because a lot of us as developers, we're on really good internet speeds. We've got either on a wired connection or really good wireless. So here's just some average latencies. So average latency, this is just to get your network request going. Wired connection, 0.3 milliseconds, it's pretty darn fast. Wi-Fi connection, 3 milliseconds. We're already an order of magnitude higher. 4G, which we've got pretty good 4G coverage, especially if you're in good metropolitan areas. Now we're already at 64 milliseconds. 3G, we're up to 152 milliseconds. Now, as we develop more mobile first and keeping in mind the international market, like we need to keep this in mind. And it's something that can be really easily overlooked because, hey, it runs fast for me. But a lot of people are consuming things on their phones. They're nowhere near even your Wi-Fi connection. So REST has this good thing and this bad problem that comes with. So here's a sample API request response from the Yelp API. This is all of the data that gives me for one singular business. It's a lot, which is exactly how REST is designed. You give me this endpoint, I'll give you all of the details about this business, or hit this endpoint, and I'll give you an array of businesses that meet this category. Like, that's exactly what REST is supposed to do. Problem, again, keeping in mind mobile, is this is a lot of overfetching. Like, you have a seriously increased payload, and it only further exacerbates itself when I now need to take some of this data and make another API call. So I have to wait for this data to get back, pull out that piece of data, make another API call, still having that latency effect. Sometimes you get 2, 3 round trips. Like, it can really start to bog things down. And if I'm looking at that API as a front-end developer, because I do most of my work as front-end, like, it just gives me a giant migraine. So here's a sample API structure for a really basic blog. So I've got users who can create blogs. So I have a user API endpoint. This is obviously somewhat contrived. Like, I'm not trying to build the most robust API example in the world. So /user gives me the user object, which also has an array of posts that they've created. And we have posts, which returns me all of the posts that they've created. I'm sure we can add some pagination in there to make it more efficient. And then posts will give me all of the data for just a specific post. So let's say I want to create an index of said posts. I'd probably hit the user API, get the array of posts, or get their ID, then hit the post API with their user ID to get all of their posts, everything. All I really care about is the title, the slug, maybe an excerpt. Like, I don't need all of that data, but I'm gonna get it because that's what REST does. It gives it to you whether you like it or not. So that's where GraphQL comes in. So according to graphql.org, that's the specification. GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. So a couple things that GraphQL is not. It is not a framework. is not language specific. You can integrate it with most major programming languages, and I have a link in the resources slide at the end that you can say, oh, I want to build a front end, I want to build a back end, here's the language. It'll give you all the libraries that you can use. So GraphQL is a specification. It was written by Facebook to fulfill their increasing graph data needs and all these interconnected queries, and to find a more efficient way to get the data that they need. So graphql.org, you can find the actual specification there, and then there's multiple frameworks that have built up several layers of abstraction to make it a whole lot easier to use. So key things first, what problems does GraphQL solve? And they have huge impacts on your performance. So you decrease your payload size because you're only getting the data that you need, and it reduces the number of round trips because I'm no longer waiting for data to come back on the client and then making another request. I'm getting all of the data that I need back in the single request. All of the fetching and all the looping is handled on the server. It increases developer experience through automatic documented APIs, which is amazing. Who here has tried to use a horribly documented API? Yeah, that's no fun. Or the documentation is out of date, or something's changed. Non-existent, even better. Yeah, just great fun, throwing the computer out the window. So GraphQL includes amazing documentation out of the box. And it updates as you build your API. You're no longer relying on someone to maintain documentation, using a system like Swagger to document your API. It's just included, and that's because of how it's set up. It also has deep integration with modern front-end JavaScript. So React, Vue, all of the modern frameworks. I think Angular also has some plugins for it, which include caching, which reduces their need to even fetch data from the back end, which again, further increases performance. So how do we do this? So GraphQL creates a declarative data structure. So you declare all of the different fields that your data structure has and what types they are. So if you aren't familiar with type systems, like this is going to be kind of new. It's not all loose and fancy free like JavaScript as we generally think of it. You can connect different data sources in the same query. So let's say I need to get some from a database, some from a third-party API endpoint, something from a Lambda function. You can include all of those in your GraphQL server through the resolvers. You also only have one endpoint, which as a front-end developer, like, that makes me so happy. I don't have to deal with environment variables of like, oh, I'm in dev, so I need to have this URL for this endpoint here, and oh, change it to this URL in production, and have to tie all of my React component codes to all of these ridiculous URLs. And oh, the URL changed. Like, you don't have to deal with any of that. You set up one URL, and then all of the queries, all of the mutations run through the one URL. It's amazing. It also enables really good mocking. So if you're developing your backend and your front end right alongside of each other, you can set up, hey, here's what the data store looks like, and you can plug in mock resolvers for the front end, and they'll pretend like they're actually getting real data from the backend, even if the backend isn't set up yet. And then when the backend's ready to go live, you just pull out that line of code and you hook it up to the real backend. And we already talked about client caching a little bit. So GraphQL uses types. So vanilla JavaScript is loosely typed. For better or worse, like, it's one of those things that people either love or hate. I will say that after getting into GraphQL, I really dislike loosely typed JavaScript, and I've gone full in on using Flow. So with vanilla JavaScript, you can have loose equality. The string of 1 equals 1. That's going to render true. And the string of 1 with strict equality to 1 is going to equal false. So when you're using loose equality, It's using type coercion to determine if the values are equal. GraphQL uses strict typing. So there's no coercion, so you can't do any loose equality. It basically treats everything like with strict equality. You declare your field types on the server. If there's any mismatches whatsoever, it's going to throw an error. Like, it gives you no wiggle room, which sounds intimidating, but then you don't actually have to worry about the structure of your data. You're going to get exactly the structure of your data that you declare, which makes development really, really nice. And you can also declare the field as nullable or non-nullable. So default types that you get with GraphQL in the spec out of the box, you have a string, an integer, float, Boolean, and ID. ID is really just a string, but it flags it in GraphQL terms as something that is not meant to be human readable. So like if you have an ID for your document ID from your database, like that's auto-generated, that's where you would use the type ID. When it gets parsed, it's still a string, but it's not something that you're going to be like printing out to the screen. So getting started with GraphQL Server, we declare all of our types for our different data. So this is actually a sample type from a React Native application that I've been building. So we declare the type with the keyword type, and then whatever we want to name it, you can name that whatever you want. And this is going to look really similar to like a JSON object without as much of the, there's no commas, like, and if you throw in commas, it'll yell at you. That might take a while. Took me a while anyways. I kept on trying to put commas on, like being the good JavaScript developer that I was. But similar to a JavaScript object, the keys on the left, the values on the right. So we've got ID, which is of type ID, created at is the type date. So here we've got the document ID from MongoDB, because that's the database that I'm using for the project. Title is of type string, and that exclamation point says that that's a non-nullable value. So every brew entry must have a title. It cannot be null. We also can have subtypes. So like JSON architecture, we're used to seeing like objects within objects. You can do that with GraphQL, but you can't just say like ingredients and then open up a new object. Like it'll throw an error at you. You have to declare a separate type, and then you insert that. So like type ingredients is just another type just like brew entry, except it has the key values of sugar, water, and tea, which actually is a further subtype. So you can nest them, but you nest them a little bit differently than traditional JSON. You can declare your own custom types, so you don't have to stick to the default types that you come out of the box. You just have to say how they're serialized and deserialized in the database with GraphQL. Declare that in your schema, and then you can use it elsewhere. And you can also use enums or union types. So the brew method, where it says allowed brew methods, that's an enum type. So it's only going to allow one of several values. So then we define our queries, which are in their own type called query. That's a reserved phrase for setting up your queries in GraphQL. And you declare the query name as the key, and then you define what it returns. So here, all brew entries returns an array of type brew entry. So they kind of build up on each other. You can also define optional arguments, again, with the appropriate types. If you're noticing a pattern, types, types, types. Which, where this comes in handy is with some tool, a great tool that ships with called Graphical and the built-in documentation. And you'll see why this is so amazing in a little bit. So brew entry accepts a singular argument, and it's a required argument because, again, we have that exclamation point. So it expects an ID, and it's going to return a singular brew entry. You can also do mutations on our database. So here we've got new brew entry, and so we've got something a little bit different here. We have an input type. So input types are different than regular types. They're set up the same, except an input type is what is declared inside those arguments. So they're very similar. Like the brew entry input is basically the same, except it doesn't have the ID field, because obviously there is no ID. It cannot be required because it has not been saved to the database yet. So a new brew entry is going to expect a brew entry input. It's going to return a brew entry. Update brew entry is going to take the ID and the input, return the brew entry, and then removing it, it's going to take the ID and delete it. So this is a lot to digest, and we still haven't even gonna, well, how does all of this actually hook up?
What are you actually brewing?
Huh?
What are you brewing?
Kombucha. Yes. I'm like a true hipster Portlander. So Schema is only half of the things with GraphQL and setting up the server. You also need to have resolvers. And so resolvers basically tell the server what in the world it's supposed to do with this data structure. So we set up our resolvers in an object map. And we've got key root values such as query and mutation. So in that object, we have, OK, all brew entries is going to return brewentry.find. Brewentry is a mongoose model that I have set up. Mutation is going to take in the new brew entry. It's going to take in the arguments and return the saved output. And I know it's a node meetup, but we still got to talk about the client because the server is only half the excitement, and where GraphQL really shines is how it integrates with front-end code. So out-of-the-box benefits is you get a data store similar to Redux without all of the boilerplate, by the way. No, there's like next to no boilerplate, which is awesome. There's been several like large organizations that have shifted from Redux to GraphQL and eliminated very large portions of their code base that was taken up with Redux. You get caching out of the box. You don't have any data massaging in the client because you're declaring the data that you want, and that's all the data that you're getting back. You're not underfetching, you're not overfetching, you're getting exactly the data that you want back, and so you don't have to massage it on the client's end. Again, you can get exactly the data that you need for each view. So for example, that blog post index, if all I want is the title of the slug and an excerpt, all I ask for is that. And that's all I get. You can focus on more developer-friendly and discoverable methods than a plethora of endpoints. Again, you've got that one endpoint, and you've got a really discoverable API, and you have an amazing tool set to help write queries faster. So here's an example of the query syntax in the client side. You open up with a set of brackets, call the query, open up another set of brackets, and say, OK, I want the ID and the title. That's going to return a data object. The root key on that is going to be the query name. And again, it returns an array of brew entries. And each one is only giving me the ID and title, because that's all I asked for. So we're going to go into the Star Wars API. And bump that up a lot. So here's what is like one of the most mind-blowing things ever. So graphical, which is not a typo, it is graphical, because apparently the people who made it were very tongue-in-cheek. Includes this docs tab. And this ships with any like GraphQL, at least with any of the major frameworks that are implementing it. And if I pull this open, the Star Wars API doesn't allow me to mutate their data. So I only have this query. So I can click on this query. And now I can see, oh, here's the all films query. And oh, it takes an argument of after. It can give me a description. You can get vehicles. You can just drill down into your API and see what everything looks like. And as my schema changes, that automatically updates because it's driven and produced by the schema. So there's no manually updating of documentation. There's no out-of-date documentation. You can deprecate certain fields on your GraphQL schema. You can include notes of why it was deprecated. You can include descriptions. Like, you get all of that out of the box. So we'll just open up a query, and we're going to say, OK, I want all films. And we'll open that up. And another nice thing is if I hit Control Space, I can see, OK, I want edges and node. They're using relay, which has this edges and node concept. And I can say, oh, I want the title, and I want the release date. And you can just start playing around with it. Character connection. Edges. You can build up really complex queries. We'll just run this. So now here's all the data that I get back. And what's really cool is, since it's just a specification, this nasty URL is actually encoding this query. So I could plug in this URL, like even if I didn't want to set up a GraphQL client in my front-end code, I could plug in that URL into a fetch call, and I'm going to get exactly that data object back. Really cool. Also, this is exactly the format that I need in my front-end code. So I always test my queries in graphical, test my mutations, get it working right, rather than having to navigate through 3 different screens. Oh, error, didn't get this data back the way you wanted. No, I'm going to do it right here. I'm going to get the instantaneous feedback, get it right, and then just copy the code over. It's fantastic. So here's some resources. The link to the slides is at the bottom. Howtographql.com is a great video tutorial series built by the folks at GraphQL, now Prisma, which do a database as a service, and will do your, like, they can set up, they do a SQL database, and you can just say, okay, here's the data set that I want and how I want it set up. They'll like auto create a lot of your schemas and your resolvers for you. You can plug in authentication. They'll set it all up for you. I mean, you're paying a service fee, but they do have some free tiers if you just want to tinker around with it. And they also did release an open source library if you want to basically use their technology, but not have as many of the bells and whistles, but run it on your own servers. GraphQL.org is the specification page. Graph.cool we just talked about. GraphQL Stack is that reference I was talking about earlier, where you can, someone like took the time, and bless them for it, and went through all of the different types of, whether you're doing backend, serverless, front end, what language you're writing in, and you just do a drop down. And it'll say, oh, well, here's the, if you're writing in Python on backend server, here's the frameworks. If you're writing in Elixir, it's amazing. Apollo GraphQL, I think, is one of the best JavaScript frameworks. They have both an Express server and a client server that they're continuing to iterate on and doing really well with. I love collecting GraphQL links because it's kind of a passion of mine. So that's my pinboard with all of my GraphQL tags. And if you're interested in checking out the kombucha log application that I'm building, it is on GitHub, although it's not being as actively developed now that I'm working full time. So, all right, well, thank you so much.